Dear students, let us begin video lecture number 2 of fuel cell, chapter number 2. In the previous lecture, we come to know introduction part of fuel cells, differences between the batteries and fuel cells, and also we discuss the concept of advantages and disadvantages of the fuel cells. Now let us discuss another two important part of this chapter are methanol oxygen fuel cell and solid oxide fuel cells. So let us begin with the methanol oxygen fuel cell. So this is the block diagram of methanol oxygen fuel cell, where you can observe there are the two compartments, anodic compartment and cathodic compartment, where at anodic compartment we are going to supply methanol with sulfuric acid dilute, and at cathodic compartment we are going to supply the oxygen gas into the cathodic compartment. In this fuel cell, what you can observe, the two electrodes we are using same metal electrodes, they are made of platinum, and it has another two arrangement, the storage for carbon dioxide gas which are produced by the redox reactions are stored in the uppermost and bottom compartment of the fuel cell. At the same time, the oxygen gas is supplied, and excess of oxygen gas and the products formed during the redox reactions are what? They are drained out from the cathodic compartment. And in this fuel cell, the fuel is used as methanol. This is one carbon containing alcoholic compound with hydroxyl group active, where oxygen is the active component which can help for the oxidation of the fuel. Let us begin now in deep the construction of the fuel cell. As you know that methanol is one of the organic compound, and it is most electroactive organic fuel, and it is operated at very low temperature because the methanol contains low organic carbon content, and it is a volatile organic compound, and it possesses readily oxidizable hydroxyl group which is available for the combustion of the fuel during the oxidation process. And one more advantage of using the methanol is what? It is highly soluble in aqueous solution. And this fuel cell is usually operated below 100 degrees Celsius, and by using the electrolyte is called 3.7 molar sulfuric acid in between the two compartments, that is anodic compartment and cathodic compartment. And as I told in the previous slide, it consists both compartments, anodic and cathodic compartments. Both are containing the platinum electrodes as anode and cathode. And methanol containing dilute sulfuric acid is what passed through the anodic compartment, and oxygen gas is passed through the cathodic compartment as depicted in the diagram. And as I explained, electrolyte consisting of ion exchange membrane, it is a polymeric membrane which prevents the diffusion of methanol into the cathodic compartment. With these conditions of operation at 25 degrees Celsius, the EMF of the cell is produced, that is what? 1.2 volts. Let us discuss in brief about the electrode reactions. As you know that we are using fuel as the methanol, and we are going to supply dilute sulfuric acid along with the anodic compartment, and we are using the common electrolyte is called the sulfuric acid, whose concentration is taken as 3.7 molar. And as I explained, the electrodes what you are using, both are made of platinum metal, and you are going to supply the oxygen gas at the cathodic compartment. That's what we can depict it from the electrode reactions. As you know that at the anodic compartment we are going to supply the methanol with dilute sulfuric acid, means it contains water. So when it methanol undergoes oxidation in the presence of dilute sulfuric acid, there is a formation of carbon dioxide gas by the loss of 6 H plus ions and 6 electrons. And at cathodic compartment, reduction is taking place by the use of 3/2 moles of oxygen gas by consuming 6 H plus ions and 6 electrons, leading to form the 3 moles of water. Now overall cell reaction what we can express by avoiding common things either side of the reactants and products. We have to avoid 6 H plus ions with 6 electrons because they have been released. The same has been consumed at the cathodic reaction by combining with oxygen gas, leading to form the 3 moles of water. Hence 6 H plus ions by 6 electrons and 6 H plus ions by the 6 electrons, that has to be avoided during the addition of reactants and products. And during the oxidation process, 1 mole of water is consumed for the oxidation reaction, and we are able to get 3 moles of water during the reduction process. Hence, if you balance this one, net formation of water molecules after cancelling 1 mole from this one and 1 mole from this, that is left now only 2 moles of water is formed during the redox reactions. Hence, we can write overall net reaction as 1 mole of methanol combines with 3/2 moles of oxygen gas, leading to form the 1 mole of carbon dioxide gas and 2 moles of water. Let us discuss now the advantages of the methanol oxygen fuel cell and its uses. The first one is methanol oxygen fuel cell. It is stable at all atmospheric conditions. We can operate at all atmospheric conditions of temperature and pressure. Second one is it is easy for handling, means it can be operated very easily. Third one is methanol has low carbon content. It means there is a less pollution by using the methanol oxygen fuel cell. There is a release of carbon dioxide gas with minimum carbon content. And as you know that methanol, it contains the hydroxyl active group which is easily oxidizable. Therefore, the combustion takes place efficiently, and as a result, what we are able to get the carbon dioxide gas with the minimum use of the oxygen. And carbon dioxide gas can be removed very easily from the respective compartments from the methanol oxygen fuel cell. Let us discuss about the uses of methanol oxygen fuel cells are what. Methanol oxygen fuel cell is used in military applications. As you know that military operations are taking place in the remote places. If there is not possible to carry out the electric supply, so we can able to carry this methanol oxygen fuel cell with their vehicles, and we can have the electric power. Hence, we can use these methanol oxygen fuel cell in military applications wherever we need to go for the power supply in the remote places. And we can use in large scale power production. So methanol oxygen fuel cell, multiple combination, we can produce large amount of power. Hence, we can use these methanol oxygen fuel cell in large scale power production plants also. So with this, the concept of methanol oxygen fuel cell is what? That is completed. In next video, we'll discuss about the construction and working of solid oxide fuel cell. Thank you, one and all.